Want to welcome you to a new week. And of course, this is week 5. And, we're gradually moving to midterm 1 exam. Today, I uploaded midterm 1 practice question. And of course, some are without solutions because those ones without solutions, they are part of the assignment, the ongoing assignment. And of course, at the end of today, or probably tomorrow, I'm actually going to update that. And of course, I'm going to dedicate a class to review the practice question together. Okay, so in the lecture, we actually want to start what we call complex regressors. We've been dealing with the complex regressors. Of course, the idea of the complex regressors is when you working with a multiple linear regression where you have a combination of quantitative and categorical predators, or you only have categorical predators, or you only have the quantitative predators. You get what I mean? So that is the idea behind that. Okay, so I'm going to work with this data set today. The National Health, Welfare, and Education Statistics for 210 places, mostly United Nations members, but also other areas like Hong Kong that are not independent countries according to the way this is described. Okay, a data frame with 237 observations on the following 32 variables. We have the region, okay, the group, fertility, per capita gross domestic product in US dollars, the female life expectancy in years, and the percent urban. I don't know whether you're familiar with the OECD countries, okay, the Organization for Economic Cooperation and Development. Okay, so this set of countries, they basically want to have economic growth, and of course they always meet and look for a way to be able to actualize that. Okay, we have these variables in place, and of course maybe our interest is looking at the effects of group, okay, on the life expectancy, on female life expectancy. If you take a look at the first equation, that's more or less like comparing life expectancy in different groups. That's what it means. And because there are 3 categories, if you take a look at the group here, okay, we got 3 categories. Okay, as you can see, the Organization of Economic Cooperation and Development as of May 2012, Africa countries on the African continent, and order for all other countries. And of course, we have no OECD countries that are located in Africa. So it's more or less like we actually are having 3 groups of these countries. Now, having 3 groups, if you look at the first equation, if I looking at the effect of group on the life expectancy of female, of course, I'm actually going to have 2 indicators because we got 3 levels of group. We're not going to use all the levels in an equation. There's going to be a problem. Or we automatically we automatically reference a particular group. The fact that we reference that group does not mean does not mean that group is inferior. No. But if we are taking a decision, if you're talking about a particular group, that will be relative to the one that was referenced. And which means the first level of the group is being referenced. And in the first level of the group, we assume that the U2, U3 equal to 0. That's what it means. The U2, the U3, the U2 is the second level of the group. The U3 is the third level of the group. And when I'm focusing on the first level of the group, it's not appearing, it's being referenced, then it means the other levels of the group equal to 0 at that particular point. Now, what are we talking about? Situation where that happened, where we're only focusing on the group that is being referenced, then we're typically talking about intercepts. Does that make sense? We're typically talking about intercepts. And that was why I said, so beta naught is the mean for the first level of group. Okay. And for the second level, if I want to consider the second level of group, in the second level of group, I'm going to code U2 as 1 and U3 as 0 because I'm only focusing on the second level. If I want to talk about the third level will be U3 equal to 1, where the second level is 0. Now, I wanted to take a look at situation where I'm focusing on the second level. If I'm focusing on the second level, there's always going to be intercept, except that the regression coefficient associated with the third level will be 0. Okay? And that was why you're seeing beta naught plus beta 2. So the beta naught plus beta 2, okay, is actually the mean for the second level of group, which means the mean of the second level of the group is beta naught plus beta 2. That's what we mean. What if I ask you in a question, what is the mean of the second level of a group? Which means when I had intercept of beta 2, that will give me the mean of the second level of the group. Okay, then how do I get the mean of the third level? It's going to follow the same way, which is just going to be the beta naught plus beta 3. Any question? Any question on these equations? I just presented to you now. Okay, the combination of regression parameters that can give you the mean of the first level of the group, the mean of the second level of the group, the mean of the third level of the group. The takeaway from here, the mean of the first level is intercept, period, beta naught. The mean of the second level is basically going to be the beta naught plus B2. And the mean of the third level is basically going to be the beta naught plus B3. That's all. That is the takeaway. Now, let's look at the data frame. This is the data frame. I told you, we got different countries. You know, these countries coming from region of the world. And in the group, we got 3 levels of the group. We got OECD, other, and Africa. OECD, others, and Africa. Okay? Because to the best of my knowledge, no African country is part of OECD. So we're talking about United States, Japan, and the like. Okay? And look at the coding. We basically have, because we got 3 levels of group, basically going to have U1, U2, U3, as you can see. Okay? So that is, the coding. So if I want to interpret the first one for you, Afghanistan, okay, Afghanistan belong to group 2. That is what it means. Afghanistan does not belong to group 1, does not belong to group 3. Does that make sense? And that is why it is coded 1. Okay, you can only Anywhere you see one, that is where that particular country belongs. Any question? So I just wanted to understand the coding. Now, based on this, we basically want to construct a graphical plot. Let me tell you this. Just like what we used to do in hospital, when the patient is sick and the patient visits hospital, doctor will not commence treatment immediately. I think you know that, right? The doctor is basically going to first conduct what I call a diagnostic testing to understand the patient, right? And to know what kind of treatments they basically, um, going to render to the patient. We also do that in statistics. When we have data set, even though we're looking at the effects of group on the life expectancy, we first do what I call data exploratory analysis. In the data exploratory analysis, that may involve constructing graph. Now, what is the graph of comparison, since I basically want to compare? The essence of this graph is just for me to have a sense of what is going on before I go into rigorous statistical analysis. And of course, a very good plot of comparison is a box plot. And as you can see, we're having 3 box plots because we got 3 levels of group. Don't forget, we actually want to compare. The response variable is the life expectancy of female in all these nations. We basically want to see whether the life expectancy of female is the same in the 3 categories. Oh my God. Take a look at the box plot. As you can see in the box plot, that is giving you a sense that they may not necessarily be the same. If you want to go by the mean, the median, take a look at that. And with the possibility of outliers, if you take a look at the OECD, I'm seeing Turkey, I'm seeing Japan, right? Possible outliers. And when you take a look at the order, I'm looking at Nauru and Afghanistan. And in the case of Africa, I think there is no any visible outlier. So take a look at that. That's sending a message. Of course, the effect plot is what you are seeing at the other side, which is also telling the same story about the fact that the mean is not the same. But let me tell you this. We know in life, there's going to be variation, right? There's always going to be difference. But in statistics, before we can call a difference, it has to be significant. Even though difference exists, as you can see in the box plot displayed, this difference may be due to chance. It may be due to chance. So how are we going to know whether it is due to chance or not? Then that is where we need to conduct a standard statistical test. But the fact remains that this is also telling a story that there's possibility, there's a difference between the life expectancy in different groups, but maybe the difference can only be attributed to variation within and not variation between. So and that's why we basically want to investigate that. And don't forget, we have an assumption: the variation within have to be constant across board, right? That was the assumption. Okay. Now, because of that, of course, this is actually called a one-way model because we're only considering the effects of a categorical predator, one factor, except that this factor has levels, and that's what makes it one way. Okay. The moment I have additional factor, it's no longer going to be one way. How do we do this in R? You know what are we doing here? What we're doing here is basically to test to be able to update our belief on what we see. In the graphical analysis, we know that there's a difference, right? And we basically want to see whether this daily difference can only be attributed to chance or is a genuine one. That's why we actually run on a linear regression model where we are regressing life expectancy, the female life expectancy on group. And of course, we're using data from United Nations. If you check the ALR4 package, of course, you're going to have access to that data. Now, when we do that, I want to pay attention to this output. Now, looking at this output, don't forget we got 3 levels, right, of the group. How many levels will be reported? It was only 2, I told you. The other one, how do we automatically reference 1? You know, here, since group order and group Africa is in display, Arrow has automatically coded, has automatically referenced the group OECD. Of course, if you want to recode, we have a way. If you don't want to make OECD, or if you don't want to reference that, do you know you can also reference any of the level depending on you? But based on what I'm showing you now, how has automatically reference the group OECD, okay? And looking at these outputs, we basically need to go by way of theory. Don't forget, the other time I said, if I'm interested in the mean of the first group, what is going to be the first group in this case? Going to be group OECD, right? That mean is will be represented by beta naught. That is the intercept. Does that make sense? The mean of the first group, level of the group, is represented by beta naught. But which is 82.446. But when you take a look at minus 7.120, that guy is the I'm gonna show you. I'm gonna write something now so that you'll be able to see. When you want to talk about the mean level, the beta naught cap, the beta naught cap plus beta 1 cap, this is mean level, the mean of level 1, mean of level 2, then beta naught cap plus beta 2 cap, mean of level 3. Now, if you take a look at this table, okay, the only one that is a mean level is the first one. Others are not mean level. Does that make sense? And if I want to make others to be mean level, and if I want to get the mean level of level 2, then I will the intercept, that means 82.446 plus minus 7.120. Does that make sense? If I want to get the mean level of the second one, and if I want to get the mean level of the third one, this is exactly what I'm going to do. Any question? Any question? If I'm talking about the mean level now. Okay. Since there's no question, it means you guys really understand that. Another thing I need you to pay attention to now, the fact that all the effects are significant. Take a look at that. All the effect, the intercept significant, the group order significant, the group Africa significant. And what does that mean? The significant, at P level, at 5% level of significance, that is actually significant, to tell you there's a significant effect of group on the life expectancy. Okay, now this is what I'm looking at the table. What I just talked about now, if you want to get the mean of the first level, don't forget the first level here is OECD, right? The mean is basically the intercept, and of course the mean of the second level that we call order is beta naught plus beta 2. Of course, when you take a look at the beta 3, of course you can see 0 is here. So that was why I said the first one beta naught, the second one beta naught plus beta 2, and the third one the beta naught plus beta 3, and that's exactly what you see in case I ask you to get the mean of each level. Okay, do you know that? What of in a situation where I basically, because there are some stuff that may not be captured in this table. In the table, if you take a look at what I just displayed now, we have an opportunity to look at the difference between the beta naught and the beta 2. We have an opportunity to look at the difference between beta naught and the beta 3, but we did not have opportunity to look at the difference between beta 2 and beta 3. That is not on the board. We don't have that opportunity, okay, between the beta 2. For instance, I basically want to make inference about the difference between Africa and others, okay. Because of that, I'm actually going to go by way of linear comparison of levels of means. Okay, what do I want to do? I want to look at the difference between B2 and B3. What does B2 represent? What does B3 represent? Okay, others and Africa. The others and Africas are now captured in the analysis that I actually did before. And because of that, okay, I need an estimator. The estimator is basically going to be held in matrix form. The A that you see is just a constant, A1, A2. If I'm, then, and that A1, A2 is basically going to be 1 and -1 in terms of weights, because I'm looking at it different. One is going to be 1, the other one is going to be -1. And that's why you see B2 minus B3. And of course, when I have an estimator, because I want to conduct an inference, I need a standard error. Don't forget, the one here, if without the standard error of the estimate, there's no way you're going to get a t-value, right? And if I'm talking about the table, do you see the table? Every estimate has its corresponding standard error. The standard error is very, very, essential in statistical inference. Without standard error, you cannot construct confidence interval. Without standard error, you cannot test hypothesis. So what I'm trying to tell you, without standard error, there's no way you'll be able to get t-value. And without t-value, there is no way you'll be able to figure out the p-value associated with that t-value. And that is the reason why we need a standard error. Okay, we need a standard error of our estimator giving S. And that standard error is just basically going to be a sigma cap. Don't forget, the sigma cap is the residual standard error, right? Then the square root of, A prime S prime X inverse A. And in the variance covariance matrix, all what you just need, I need C22, C33, and C23. When I'm talking about B2, B3, look at that, B2, B3. When I'm talking about B2 and B3, don't forget, I'm looking at the difference between B2 and B3. Automatically, I need C22, C33, and C23. I mean, and that's what you see there. Okay. And you may be wondering, how do we get that? How do we come to using that formula? I'm actually going to show you now. Okay. Our head is beta 2 minus beta 3. Okay, just like what I'm trying to show you. Now, what is the variance of L? It's going to be the variance of beta 2 minus beta 3. If I basically, using the law of statistics, it's basically going to be the variance of beta 2 plus the variance of beta 3 minus 2 covariance beta 2, beta 3. Whether you have a minus, okay, the only difference here, if I have a plus, okay, the covariance is just going to be a plus. So I just wanted to take note of this. Now, the variance of beta 2, if you look at the variance covariance matrix, where the other time it is this X prime, X inverse, and of course, it is basically C11, C22, C33, C12, C13, C21, C23, C31, C32, where these guys are the variances. And that is the reason if those guys are the variances, if I'm interested in B2 and B3, okay, so right here, that's why you see me using C22, C33, okay, and minus 2 times that, then the sigma cap. Okay, so that is how we formulate that. But let me tell you this, super easy with how. I'm going to show you how you're going to figure that out now. This guy here, this guy is called variance covariance matrix. The variance of beta means variance covariance. Why is it called variance covariance matrix? Because the diagonals are the variances, half diagonal are the covariances. And how am I going to get that in R? Oh, CVOV into MOD. What is my MOD? I'm going to go back now. Oh, that is my MOD, right? MOD equal to LM. You see that now, right? If I want to get the variance covariance matrix, you don't need to go mathematical. That is the essence of the lab. Okay. The moment you do COVOV, it's going to give you 3 by 3. Don't forget you got the beta now, the beta 2, the beta 3. Don't forget. Okay. Now take a look at that now. Now from that guy now, I want to get this guy. I want to get this guy here. Okay. Now the 1.651, that is, don't forget, group order, where the group order meet group order is C22. You remember here? C22, right? Okay. Where the group order meet group order. Okay. Then 2.01 is where the group Africa meet group Africa. That is the variance of the group Africa. Then minus 2 times the 1.27 that you see now is the covariance between the group Africa and group order. You know what you want to do here? You basically want to look at the difference between group Africa and group order. That is not part of the regression output initially, and that was why you're trying to figure it out this way. Then you get the variance, because this guy is just going to give you the variance. But what I need is the standard error of that, which is going to be the square root of the variance of that. And that's why you see in our SQRT is the square root. Now this guy 1.042641 is the standard error that I need. If I want to conduct inference on beta 2 minus beta 3, whether I want to construct a confidence interval or I want to I want to construct an hypothesis testing. Is there anybody want to ask a question? So far so good, right? Okay, you pay for the service. The moment you don't understand, please let me know. You good, right? Okay. Now, take a look at this now. I now want to put that result in the table. What do I want to compare? Because the moment I got this guy, the moment I got the standard error, and I know the difference, what would be my test statistic? My test statistic would be the difference divided by the standard error. And the moment I got that, I will be able to get my p-value. Don't forget, I'm actually comparing group order and Africa. I'm comparing group order and Africa. Take a look at the table now. Now I have group order and Africa. You see now? Initially, the very first two were part of the original arrangement. The very first two were part of the original arrangement. But the third one, we just put that. Look at that. SE, standard error 1.04 is the one that we just figure out. 1.04 to 2 decimal. Go ahead. Oh, you mean here? That's a very good question. We're using this guy. This variance equal to this. So if I want to, if variance equal to this, the standard error is going to be the square root, which means the square root of this sigma, and the square root of this guy is what you see. You see that guy is under square root? No. Oh, okay. You know what happened? The variance covariance formula that we use, this guy, this CVOV has already taken care of everything. I understand where you're going. So the CVOV here, where's that? Okay, the COV here has also considered the sigma square as part. That is why it is called variance covariance. That's a good question. It means you guys are following and begin to like this class now because you guys are contributing. Now, does that make sense to you now, right? Okay. Now, when we write an arrow code, of course, the estimate 50.55, where does it come from? The group minus the group, that one can come from the table here, okay? Minus 7.119 minus 22 point whatever, don't forget, you're looking at the difference between the group, order and Africa, right? And that will give you 15 point something that you are seeing in the table, 50.55. Do you see that? Okay, you are the standard error now. The moment you have the standard error, you can talk about the t value, which is going to be the estimate divided by the standard error. Then from there, I'm going to get a p value associated with that. That will be super easy. My TA is going to walk you through how do we write a p value for this. That's super easy. Go ahead. Oh, okay. It's the difference between this and this. So like you're going to go back to the table. We looking at the difference between order and Africa, right? What is the estimate for order? It's minus 7.1197 minus 22 points. You can see, right? You get it right. So that's how the 50.55 came up. Now, with what we have done now, we've seen that there's a significant difference, right? Between the life expectancy in order and Africa. That is exactly what we've been able to figure out. So when you take a look at the comparison that we have now, we can talk about the difference between OECD and order in terms of a female life expectancy. You can see that there's a significant difference. There's also significant difference between OECD and Africa and between order and Africa. The order and Africa was not initially, the difference between that was not initially captured in the arrow analysis that you run, and that was why you did a special one. Take a look at what I have here. At times, we just look at the effects of group on life expectancy. What of in a situation where there's a particular potential factor that may be influencing that difference? You remember what we did last week, right? And because of that, we also want to consider the GDP, okay, per capita GDP. Okay, you remember the other time we actually incorporating covariates, right? The covariate here, the primary variable of interest is group on life expectancy. The group is a primary explanatory variable of interest, but we believe that another potential variable, okay, that could have effect on the life expectancy is PPGDP. We're now incorporating that. When you take a look at the first plot, it's like plotting the life expectancy against the group and putting into consideration the GDP. And when you take a look at that now, you are not seeing a straight line. There's no straight line, right? And you can see now, you can see the first one is what we call the effect plot for the interaction model, okay? And the second one is when we realize that there was a linearity violation when we look at the relationship between the life expectancy and PPGDP. We now decided to look for a transformational effort by trying to take the log of the PPGDP. When we take the log of the PPGDP, we achieve linearity. Only that here we can only, the interpretation is going to change because we can only measure the effect of PPGDP on a logarithmic scale. Don't forget, it was when we consider the log of that we are able to attain linearity absorption. Now, because of that, I now extended my model. This is not the model we started with initially, right? We started with the group, right? The levels of the group that you saw, that you're seeing now in equation 5.8. 2 levels, right? Don't forget, we got 3 levels. It's only 2 that will be reported. The other one will be referenced. Now we are incorporating a covariate. That's X now represent the PPGDP. But we're doing that on the log scale. Oh my God. When we now incorporate the new variable, which is the log PPGDP, let's look at the output. Okay. So the output is what is being displayed. Okay. When you incorporate that, you realize that the p-value associated with order is now greater than 0.05. Can you take a look at that? Don't forget, initially, when we did not consider other factor, right? They were all significant on their own. But right now, that order is no longer significant, as you can see. Okay, so the plot you're seeing now is, trying to compare the life expectancy, in the 3 groups. Okay, and of course, when the PPGDP is involved, like separately, for the PPGDP without the log, that's exactly what you're seeing. Okay, now when you take a look at this table here, this is like, I don't test interaction effects. I'm only looking at the main effect of group and the main effect of the PPGDP on the log scale. No interaction effect. The R square for this was 0.7422, and the residual standard error is 5.1798. But what of in a situation where I now incorporate the interaction? I think I told you in the other time that where do we need interaction effects? The interaction effect will change what? The interaction effect will change the what? The slope. You remember the other time? The other effect that was introduced may change the constant, right? I mean, the intercept, right? Okay. Now, when you are actually going to have an interaction, then the new variable will interact with each level of the group. Don't forget, initially, the level of the group that you have that was reported was order Africa, where OECD was being referenced. But right now, okay, the new variable you introduce, okay, will be able to test the main effect of that new variable as well as the interaction of that new variable with the other 2 levels. Any question on what you're seeing in the table now? Any question? Now you have the interaction of order and the log of PPGDP. You have interaction of Africa and the log of PPGDP. So this is the way. This is here now is like testing both the main effects and the interaction effects. Don't forget, the main effect of the primary variable of interest. The primary variable of interest is actually the group. Initially, we incorporated log PPGDP, and we also realized that maybe the relationship between the group and the life expectancy of female may actually depends on the log PPGDP, and that's actually account for the interaction. If I really want to know whether the interaction is significant, if you take a look at the p-value that I have now, oh my God, with the it's like interaction as complicated issue. You know why? Look at the p-value. What was the p-value? The p-value is actually greater than 0.05. And somebody may begin to say, maybe interaction is not really necessary. Maybe what is actually necessary is just to just compare the main effects of the group and the main effect of the log PPGDP, because when you do that, you can see some the significant effect. But let me tell you this: if I have series of modules, what you're basically going to see in our subsequent lecture, how do we compare between modules? Okay, because we don't just look at significance alone. We have a special test. Okay, if I want to, instead of, if I really want to know whether I should go by this model that have interaction, or I should go by this guy here without interaction, but with the main effects of growth and the main effect of PPGDP, or I should go with just the one with this guy only. Okay, we have a standard test that we're basically going to use for that, which we call a nested F test. Okay, in a subsequent lecture, we're actually going to use nested. Why is it nested? Because the simplest form of the module is in the second module. The second module is in the third module. That's why it is nested. And of course, we're basically going to use a nested ANOVA, which we call the nested F test, to be able to figure out which one is the best. Now, before I go, the fact that a module has so many parameters does not mean it's adequate for situation. The fact that a module is simple does not mean that it's not appropriate. We can have a situation where a complex module is not necessary. We can have a situation where simple module is not necessary. So we don't base the complexity or the simplicity of a module. We don't base it on the appropriateness. We have a way to investigate. Okay, that's where I'm going to stop today. That's going to be the the final slide. The story continues, just like what I used to say.